I'm looking for kernel combinations that work correctly and effectively model data that isn't simply a straight line. I need to understand which mathematical operations are valid when combining kernels and which kernels are capable of capturing complex, curved relationships in the data. This option combines a radial basis function kernel, RBF, which is great for modeling nonlinear relationships, with a constantkernel that adds a constant value. I find this a valid and commonly used combination. The RBF handles the curves, and the constantkernel helps adjust for any overall offset in the data. It's a good one. Here, I see a dotproduct kernel, which models linear relationships, multiplied by a whitekernel, which adds noise. While mathematically valid, this combination isn't ideal for modeling nonlinear relationships. It primarily captures linear trends with added noise. This option combines two kernels, matern and rationalquadratic, both of which are excellent at capturing nonlinear patterns in data. I consider this a valid and useful combination that provides flexibility in modeling various complex shapes. This is where things get tricky. Directly subtracting kernels like this is generally not supported in Sklearn. It's likely to cause numerical issues and result in an invalid kernel. I see this as an invalid combination. It's important to follow the rules of kernel arithmetic. This is just an instruction to select all the options that correctly model nonlinear relationships. This indicates that a kernel combination is both mathematically sound and effective at modeling nonlinear data. This means the combination works mathematically, but it doesn't perform well in modeling nonlinear data. This shows that the combination is incorrect and will not work within the Gaussian process framework. This question tests your knowledge of different kernel functions used in Gaussian process regression, GPR, a machine learning technique for modeling relationships between data points. We'll explore which kernel combinations are valid and useful for capturing nonlinear patterns in your data. I'll explain the options and how to evaluate their validity and usefulness. Let's get started. This question asks you to identify combinations of kernel functions within the scikit-learn library that effectively model nonlinear relationships. A kernel function defines how similar data points are. Combining them allows flexibility. We need to evaluate if each combination is mathematically sound, valid, and suitable for detecting nonlinearity, useful. It is all about choosing the right tools for the job. Fun, right? This combines a radial basis function, RBF, kernel with a constant kernel. The RBF kernel models nonlinear relationships, while the constant kernel adds a constant bias term. This is a common and valid combination often used to improve the model fit. Think of it like adding a baseline to your data. This combines a dot product kernel with a white kernel. The dot product kernel models linear relationships, and the white kernel adds noise. While mathematically valid, this combination is not suitable for modeling nonlinear patterns effectively because dot product is inherently linear. The noise addition is not the solution to the nonlinear data modeling. This combines a mattern kernel with a rational quadratic kernel. Both are capable of modeling nonlinear relationships, but with different characteristics. Combining them provides flexibility and a potentially superior fit to the data. It offers greater modeling flexibility than using one alone. A powerful combination. This attempts to subtract a linear kernel from an exp sine squared kernel. Subtracting kernels directly is generally not a supported operation in Gaussian processes, leading to numerical instability and invalid results. It's not a valid combination. You cannot just subtract kernel functions like that. We're tackling a problem where we use Gaussian process regression, GPR, a powerful machine learning technique, to model data. The core of GPR is the kernel, which defines how data points relate to each other. We're exploring different kernel functions to find the best model for our dataset. The goal is to pick kernels that accurately capture the relationships within our data. Think of it like choosing the right tools for a job. This question asks us to identify which combinations of kernels are both mathematically correct and effective at modeling relationships that are not simply straight lines. We need to carefully consider how different kernels work together. Let's dive into each option. This combines a radial basis function, RBF, kernel, which is great for nonlinear relationships, with a constant kernel that adds a constant value. I find this to be a valid and very useful combination because RBF captures the complex relationships, and the constant kernel helps fine-tune the model's overall output. It's a classic. Here, we're multiplying a dot product kernel, which models linear relationships, with a white kernel, which adds noise. While this is a valid combination, it's not ideal for nonlinear data because the primary modeling component is linear. Adding noise doesn't change that fundamental characteristic. It's valid, but not particularly helpful for our nonlinear goal. This option uses a Mattern kernel and a rational quadratic kernel, both of which are known to model nonlinear relationships. I view this as a powerful and valid combination offering increased flexibility due to the diverse nature of the component kernels. This is a good one. This attempts to subtract a linear kernel from an exp sine squared kernel. Subtracting kernels is generally not a valid operation in the GPR framework because it often leads to instability and incorrect results. This one's a no-go. This is the instruction to select all answers that satisfy the criteria of the question. Based on my analysis, options A and C are the only ones that meet these requirements. We're choosing the best kernel function for Gaussian process regression, GPR, a powerful tool for modeling relationships in data. Think of a kernel as the function that defines how data points influence each other. A good choice will give us accurate predictions. This is the core question. We need to identify which combinations of kernel functions are mathematically sound and will effectively capture nonlinear patterns in the data. We'll explore several options to see which work best. Here, I'm combining a radial basis function, RBF, kernel, which is great for nonlinear relationships, with a constant kernel, adding a constant offset. It's a common and effective combination. I think this is a valid and useful approach. This combines a dot product kernel, which models linear relationships, and a white kernel, which adds noise. While valid, it won't capture nonlinear relationships well, so it's not ideal for this problem. This is another good one. I'm adding two kernels, both capable of modeling nonlinear relationships, Mattern and rational quadratic. Different combinations offer flexibility to adapt to various data structures. I like this option, it's valid and useful. This is problematic. Subtracting kernels is generally not allowed within GPR's mathematical framework. It can lead to errors and instability. Therefore, it's an invalid approach. This describes options A and C above. Both options use appropriate kernels that accurately model nonlinearity and are mathematically sound within the context of GPR. This is option B. While the combination is mathematically valid, it doesn't capture nonlinearity effectively. This describes option D. Subtracting kernels is not permitted in GPR, and thus the approach is incorrect. This quiz focuses on choosing the right kernel combinations for Gaussian process regression, GPR, a machine learning method used for modeling data. We'll explore different kernel functions and how they combine to effectively capture the underlying patterns in the data. Let's dive in. I'll help you evaluate different kernel combinations, mathematical functions that define the relationships between data points, to determine which ones are suitable for modeling data where relationships are not simply straight lines but curves. I'll explain how different combinations work and why some are better than others for this purpose. This is a fun one. This combines a radial basis function, RBF, kernel, which models smooth, nonlinear relationships, with a constant kernel that adds a constant value, acting as a bias term. This is a valid and commonly used combination for improving model fits. Think of it as adding a little bump to your model for better accuracy. Here, I'm combining two different kernels. The Mattern kernel, which handles various degrees of smoothness, and the rational quadratic kernel, also good for modeling nonlinear data. Using both provides more flexibility to fit diverse data patterns. It's like having two different tools to work with, ensuring you have the right one for the job. This combines a dot product kernel, which models linear relationships, with a white kernel that introduces noise. While valid, this isn't helpful for modeling nonlinear patterns because it primarily captures linear relationships and adds some randomness. This attempts to subtract a linear kernel from an exp sine squared kernel, which models periodic, nonlinear relationships. Subtracting kernels in this manner isn't generally supported within the framework of Gaussian processes and usually leads to errors or instabilities in the calculations. This is not a valid or useful approach. This quiz focuses on choosing the right kernel combinations for Gaussian process regression, GPR, in Sklearn. GPR is a powerful tool for modeling relationships in data, and the choice of kernel significantly impacts the model's performance. We'll assess which combinations of kernels are mathematically sound and effective at capturing nonlinear patterns in data. This combines a radial basis function, RBF, kernel, excellent for nonlinearity, with a constant kernel, adding a constant offset. I find this combination valid and useful because it often improves model fit. Here, I see two nonlinear kernels, Mattern and rational quadratic, are added together. This is a valid and flexible way to model complex nonlinear relationships. I find this combination valid and useful. This combines a dot product kernel, for linear relationships, with a white kernel, for adding noise. Although mathematically valid, this combination isn't ideal for nonlinear relationships. It's useful only if I'm specifically modeling a linear relationship with noise. Directly subtracting kernels, as in this case, generally isn't supported by the Gaussian process library. I find this combination invalid because it's likely to cause numerical instability and problems. This quiz focuses on choosing the right kernel functions for Gaussian process regression, GPR, in Sklearn. We'll explore different kernel combinations and determine which ones are valid and useful for modeling relationships in data, specifically nonlinear ones. Get ready to dive into the exciting world of kernel functions. Let's go. This question tests your understanding of kernel functions in Gaussian process regression. We are trying to find combinations that accurately capture nonlinear patterns in data. I'll guide you through evaluating each option and explain the reasoning behind each selection. This combines a radial basis function, RBF, kernel, which is excellent for nonlinear relationships, with a constant kernel, which adds a constant bias. Adding a constant offset is frequently helpful, improving model fit. This combination is valid and very useful for modeling nonlinearity. It's a great choice. This uses a dot product kernel, which is linear, and multiplies it with a white kernel that adds noise. It's valid, but combining a linear kernel with noise isn't ideal for modeling nonlinear relationships. It's primarily useful for linear data with added randomness. Not our best choice for nonlinear modeling. This combines two kernels, Mattern and rational quadratic, both capable of handling nonlinearity. Combining them gives flexibility and more power to capture complex patterns in your data. It's another excellent and valid choice for modeling nonlinear relationships. Subtracting kernels in this way isn't typically supported in Gaussian processes. It's mathematically problematic, leading to an invalid kernel. It will most likely give you errors and won't work as intended. Avoid this option. This refers to the valid kernel combinations, A and C, that successfully model nonlinear relationships. These are great. This describes option B. While mathematically valid, it doesn't effectively capture nonlinear patterns. Keep in mind the limitations. This points out that option D is an invalid kernel combination. Subtracting kernels isn't a standard operation in the Gaussian process framework. It's not going to work.